Hi, this is John with SysEng Quick. Today I'll be showing you how to create Proxmox virtual machines from a template with Ansible. This is the first tutorial in a series on using Ansible to build a highly available Kubernetes cluster. In the Proxmox UI, we need to create an API token for Ansible to use with Proxmox. Select Data Center from the primary sidebar, and under Options, make sure Permissions is expanded and select API Tokens. Click the Add button to create a new token. Select the user to associate with the token. I'm going to pick the root user, but we'll leave privilege separation enabled so it won't have full root access. The token ID can be any string. I'm going to use demo here. I recommend setting an expiration date for the token. I'm just going to pick tomorrow to make sure this token expires before the video goes live. Click the Add button to create the token. You can see it tells you to record your API token secret. It won't be able to be viewed again. Let's copy the secret value. I'll go over to VS Code, open a new editor, and paste the secret in there for safekeeping. Now I can close the token secret and the token has been created. Because we used privilege separation, we need to assign permissions to the token. Click on Data Center Permissions and click the Add button and select API Token Permission. The path should be root. The API token is the token you just created. I'm going to use root at pam bang demo, and the role I'll change from no access to PVE admin and leave propagate checked. Click the Add button to assign this permission to your token. For our K8s cluster, we'll be creating 5 virtual machines, 3 control planes, and 2 workers. Rather than run through the install process 5 times, we're going to use a cloud image. In VS Code, I have my workspace open in a dev container. There will be a link to the GitHub repo in the video description. If you don't want to use the dev container, you'll need to install ansible-core, the community.general collection from Ansible Galaxy, and the Python modules proxmoxer, requests, and pyyaml. The dev container details will be covered in a separate video. In this very long path, we have an Ansible group vars file named cluster.yaml, which defines our cluster configuration. You'll need to tailor this file to your environment. The first key, cluster network, defines network details for the VMs that will be created in Proxmox. Here, my network is a /24 with a gateway of 192.168.1.1. The cluster nodes key defines the nodes we will build for our cluster. The playbooks are configured to use static IP addressing. Make sure any DHCP servers are configured to avoid assigning the IPs you define here. DHCP reservation is another option, but is outside the scope of this tutorial. Here I define 3 server nodes, also known as control planes or masters, and 2 worker nodes, also known as agents or minions. The node SSH user key is the user that will be used to connect to the nodes. Cloud init will create this user for us and give it full passwordless sudo privileges. The Proxmox server key defines the name of the Proxmox server that will be used to create the VMs. The Proxmox SSH user is the user Ansible will use to connect to the Proxmox server. This user must be able to run the qm disk import command as root. Once you have made your adjustments, you'll need to regenerate the inventory file. Open a terminal and type python3 scripts/update create_inventory.py. This will regenerate the inventory.yaml file in the project root. And if you change anything in this file, you should see that your inventory.yaml file looks different than mine and will match the values in cluster.yaml. Let's kick off the create cluster playbook. In the terminal, we'll run ansible-playbook sysng-quick.k3s.create_cluster. We'll go ahead and prefix that with time, and at the end, we'll redirect standard error to standard output. And we'll pipe the entire output into T, going to a log file called ansible-create_cluster.log. We'll come back to check on the output later. While that's running, let's look at what our playbook is doing. Create cluster is just a meta playbook to run other playbooks. It's going to call create template, create nodes, prep nodes, and finally snapshot cluster. Create template is our first playbook with some actual tasks. It connects to the Proxmox host and includes a vault.yaml vars file. The only task is to include the create template task from the Proxmox role. The first task tests if Ansible can become root. I often forget to supply a become password on the CLI, so this is here to stop the playbook quickly if it would have failed later. If anyone knows of a better way to handle this, please leave me a comment. The next task creates the Proxmox VM, which will be converted into a template later. The first 4 arguments are used to access the API. The remaining arguments are configuration for the VM. Most of these settings are boilerplate. Things such as name, CPU type, core count, memory, Proxmox node, OS type, and serial console access. Other settings are less obvious. We need to enable the agent for QEMU guest agent to work. We disable the memory ballooning device in case hardware pass-through is desired at some point, although we aren't doing that in this tutorial. We haven't attached any disks yet, so we pre-configure the boot order to the disk we'll be adding later. The network device is added to the bridge network with the Proxmox firewall disabled and the MTU set to match that of the underlying bridge device. We set up a cloud init disk and configure it with username, password, SSH keys, and a default DHCP network configuration. We configure the SCSI controller to use virtio SCSI single so that we can use IO threads on the disk. Finally, we set the virtual machine ID that Proxmox uses to identify the VMs. Although we are connecting to the Proxmox host here, we delegate all of the API tasks to localhost. This is because we need additional Python modules that may not be installed on our server. The next set of tasks are inside a block. We'll come back to why later. The first task downloads the cloud image to our Proxmox server. To maintain idempotency, we check to see if there is a SCSI 0 disk already attached to our template. We interpret the result and save that to the template attached disk variable. Depending upon the result, we move on to the task in the next block. These next tasks illustrate a small obstacle with the API. Only the root user can create VM disk from local disk files. I could not find a way to scope any token to grant this permission. I don't like using account passwords for API access, and certainly not the root password. To work around this, we grant sudo access to the Ansible user so that they can issue the qm disk import command as root. Everything else is done with the API on a more narrowly scoped token. When the qm disk import command is run, it will always create a new unattached disk on the VM. To make sure we aren't creating extra disks, we first check to see if there is an existing unused disk on the VM. The API task will fail if it cannot find the disk, so we set failed when to false here. The result is interpreted and saved in another variable, template disk created. The next block presents a security trade-off. We only need sudo privilege for a single command, qm disk import. But to use ansible become, more sudo privileges are required. It's easier to give full sudo access and use ansible become, but scoping the sudo access to a single command might be more secure, even if you grant the access passwordless to work around the lack of ansible become. Let me know what you think in the comments, but I decided to give my user passwordless sudo access to the qm disk import command and not use ansible become. You can configure it to use ansible become with the proxmox use become variable, which we'll cover later. Inside the block, we have two tasks. One uses sudo explicitly in the command, and the other uses ansible become. For the explicit sudo, we add the -n option so we are not prompted for a password. Without this, the task could hang waiting on a password that Ansible does not know how to supply. Next, we attach the unused disk to the VM. The community.general Proxmox module considers changing disk attachments potentially unsafe, so we need to tell it it's okay here by setting update and update unsafe to true. Here we come to the end of the original block that created our VM disk. In the Always section, we add a task to remove the disk image we downloaded if Proxmox image delete is true. The cloud image disk is probably too small for our needs, so the next task resizes it as specified in Proxmox template.size. Next, we update the disk properties for SSD disks. We enable discard for trim operations and enable I/O threads for better performance. This last task converts the VM into a template. This allows us to clone it into a new VM with the same properties. The next playbook is create nodes. These tasks just use the Proxmox API, so we run them from localhost and remove the need to delegate. The single task here runs loop nodes on the Proxmox role. This is a helper that loops over all of the nodes and runs the task file specified in Proxmox loop task. In loop nodes, we pass the current node as the node variable. The create node task file is where the actual work is done. We clone the template to a new virtual machine and set it to be a full clone. The clone property is the name of our template and is required to create a clone, but VMID is always preferred over the name. This helps to disambiguate between templates that might share a name. We save the VMID of the new virtual machine and update the IP configuration to be static. Now we start the node with the start node tasks. This is broken out here because it is used in multiple places. Occasionally during testing, the Proxmox server didn't keep up with Ansible, and some tasks would fail as a result. We use pause for Proxmox to introduce a delay to give Proxmox some time. This delay can be adjusted if your server is faster or slower than mine. The last task starts the node. We can do this by name or VMID. Using VMID is preferred to avoid name collisions, but either will work in most cases. The next playbook is prep nodes. Here we connect to all the K3s hosts in the inventory. The K3s hosts include all the nodes defined in cluster nodes in cluster.yaml. As with the other playbooks, we run a task file from the Proxmox role here. The node prep is fairly simple. We start by waiting for the node to accept our SSH connection from Ansible. While testing various cloud images, I found some packages might not be installed. We install IP tables and QEMU guest agent here for consistency. Another thing I noticed during testing is that Cloud Init may have a lock on the package manager causing the package module to fail. To work around this, we add a retry with delay. This has worked well for me in testing, but your mileage may vary. Finally, we start the QEMU guest agent and make sure the Ubuntu firewall service is disabled if it is installed. The last playbook takes a snapshot of our cluster nodes. We make sure the Proxmox snapshot variable is defined, and then we take the snapshot. That covers all of the Ansible tasks. Let's check back in on our playbook run. Back at our terminal, it looks like everything completed successfully. It took about 3 minutes to build our cluster. Let's try logging in to one of the nodes. I'll do ssh pve at worker1.k3s.local.technoplaza.net, and yes, it's up. Let's check in on our Proxmox UI. Yeah, we have new hosts here. Here's our template, and here are all 5 of our nodes. Everything looks like it's working properly. One more thing I want to go over is the Proxmox role defaults. There are things that might need some adjustment before it will work in your environment. Inside the Proxmox role defaults file main.yaml, we can see at the top the values used to access the API. The host defaults to the Proxmox server set in cluster.yaml. The token ID and user must match what you set up for your Proxmox token. I created my token on the root account and called it Ansible. The token secret is defined in the vault Vars, which we'll look at shortly. Proxmox image delete determines whether we delete the cloud image that is downloaded when we create the template. Proxmox image dest is where the cloud image is downloaded. I placed mine in /temp and kept the file name from the server. Proxmox node is the name of the node in your Proxmox cluster where you will create the VMs. I don't have a multi-node Proxmox cluster, so I used my only node. If you do have such a cluster with shared storage, you should be able to migrate any of the VMs to a different node in the cluster, but I am unable to test that in my setup. The Proxmox template dictionary defines the template settings. Block storage is false here because I am using disk image files. If you are using a block storage, such as LVM or ZFS volumes, set this to true. Bridge determines the Proxmox device to which your virtual network card will be attached. This playbook doesn't currently support any other kinds of networking. Feel free to submit a pull request if you have a different use case. The CI user and CI password are the user and password for Cloud Init. The CI user is copied from the node SSH user defined in cluster.yaml. The password is set in the vault Vars file. Cores is the number of CPU cores for the virtual machine. The disk format is what format your VM disk is using. I am using QCO2 file images, but you could change this to something else like RAW or VMDK if you prefer. If you set block storage to true, this will be ignored and assumed to be RAW. The image property determines which cloud image to use for our template. It is referencing a definition in the Vars file in this role, which we will examine later. Here I'm using Debian Bookworm. Memory is the amount of RAM in megabytes. That's powers of 2, not 10. And name is what you want to name the VM template. This is purely cosmetic. Change it if you want. Size is the total size to expand the disk image to. Most cloud images are around 2 gigs, which is often too small to run even a test K8s cluster. I've set it here to 10 gigs. SSD should be set to true if your underlying storage is on SSDs. Otherwise, set it to false. SSH keys is a list of public keys to add to the Cloud Init user. You'll definitely want to change this, as most cloud images disable SSH logins using passwords by default, and obviously my key won't work for you. Storage is the Proxmox storage pool to place your VM disk on. If you're not using the local disk storage, you'll need to change that. The VM ID is the ID to give your template. So long as it doesn't conflict with any existing VM ID, it doesn't really matter. People often use high numbers for templates, so they appear farther down in the VM list. The Proxmox timeouts are how long to wait for certain tasks to complete. The API time is used when creating the clone, as it might take longer than the default 30 seconds. The creation time is the delay we add between Proxmox operations while we're waiting for the server to catch up. And the startup time is how long we wait for the node to accept our SSH connection. Finally, there is Proxmox use become. It's probably easier to set this to true and use an account on your Proxmox host that has full sudo privileges. You may need to add the ask become pass flag when running Ansible Playbook to supply a password. Let's take a look at the Vars vault.yaml file. It's in Playbooks, Vars, Proxmox in the collection directory. This file is encrypted with Ansible Vault and contains my secret values. Since I can't share the contents of this file, I created a vault.example.yaml file which lays out the structure. To make your own vault.yaml file, simply copy the contents of this file over vault.yaml and fill out the values. Let's go grab that token secret I made at the beginning of the video, and we'll replace the token secret with that. The CI password is only used for serial console login, so it's not super useful, so I'll go ahead and use the same password there. If we want to encrypt this vault file, we need to create a password file. I've placed mine in private Ansible Vault sysng quick, and the file is named K3s. Let's open this file and create a password. It doesn't matter what it is. Just pick something. And make sure you keep that password so you can encrypt and decrypt your Vault file later on. We'll go ahead and save this file. And we'll go ahead and save vault.yaml. And if you're using VS Code and this dev container, I've added an extension which will let you encrypt and decrypt the value by pressing Ctrl-Alt-0. And it might look like it didn't do anything, but if we go away and come back, it is now encrypted. And again, Ctrl-Alt-0, and it will decrypt the value. Again, it might need to refresh, but there we go. Now, if you're on a Mac, that might be Command-Option-0, but I'm not entirely sure. Finally, let's open the Proxmox role vars main.yaml file in the Proxmox role folder. This defines variables that are not generally intended to be changed, mostly templated variables for ease of use elsewhere in the playbook. The part I want to talk about is the Proxmox images dictionary. This defines the cloud images that can be used with this playbook. I've mainly been testing with Debian Bookworm, but these other images should work. To use a different cloud image, simply update the image key in Proxmox template dictionary to reference one of the keys in this dictionary. That's everything I wanted to cover in this tutorial. In the next video, we'll use Ansible to deploy a highly available Kubernetes cluster on these nodes. I hope this has been helpful. If so, go hit those like and subscribe buttons. Thanks for watching.